Hello class, today we are going to talk about midpoints and also how to partition a line. Now before we get into some of this stuff, we want to come over here and we're going to take some notes about midpoints. Definitional stuff. This is going to be some easy stuff right here. So, first off, midpoints. What is a midpoint? Right? So the midpoint of a segment comes from middle, and point being a point. So what this is a point in the middle of the segment. And the technical definition is it is a point that divides a segment into two congruent segments. All right? So this is a point that divides the segment a segment, that's nice, segment into two congruent segments. Two congruent segments. Two congruent segments. That's lovely. We're going to draw a picture of it. Things make more sense when they are illustrated, right? So let's do that. Okay. So we need a segment, not a line. We're going to draw a segment here. We'll put it like that. We will say that this is segment A, B. And we need a midpoint, which I'll put right here in the middle. I will call the midpoint point M. M for midpoint. And very important here, has to be two congruent segments. And to mark that, so we know that these are congruent, we put a little tick mark right there. And remember, that means that these two segments are congruent to each other. All right. So what does this mean? Another thing midpoints mean. All right. If M is the midpoint, all right, M is the midpoint of segment AB, then segment AM is congruent. Remember, this is our symbol for congruent. It's an equal sign with a squiggle above it, to segment MB. And remember the definition of congruent segments. What this means is the length of AM, so no bar above it, equals the length of MB. All right? All right. So that's midpoint. Pretty simple stuff there. We need to talk about one other definition really quickly, and that is segment bisector. All right? So, segment bisector. Okay, so segment, obviously we're talking about something to do with segments. Bisector, does you know remember what bisector means? Hopefully you do. Bi means two, and sect means to cut. This is something that cuts a segment in two. Specifically, this is anything, point, line, plane, ray, whatever, anything that intersects a segment at the midpoint. That, whatever. Intersects a segment at the midpoint. All right. Again, pictures help, right? So let's get a picture. Need a segment. There we go. And we'll call this segment AB again. There it is, segment AB. It's got to intersect at the midpoint. So we'll have point M for the midpoint, and we need something intersecting it. So we will just draw a line right here, and we will call this line CD. All right. Now, how do we know that that's the midpoint? You can't just say, hey, it's a midpoint. No, it's got to be marked that way. All right. So tick mark there, tick mark there. Now we are marking that AM is congruent to MB. Not the way that we had here, right? So what we have is that line CD is a segment bisector of segment AB. So what does that mean? What that means is that segment AM is congruent to segment MB, and the length of AM equals the length of MB, just like it did up here with midpoint, because it goes through the midpoint. All right? And so there it is. Now, remember, segment bisectors can be anything. So it could be line CD, it could be segment CD, it could be ray MD, it could be ray DC. Doesn't matter. You could even have a plane there as the segment bisector. All right? All it has to do is go through the midpoint and therefore cut the segment in half. So we have two congruent segments. All right, so this is all lovely. This is great. What can we do with it? Well, we can do some things like this. Let's get an example problem over here. So first we want a picture. So I'll just make a picture here. I want another segment. And again, we'll call this segment AB, because why not? We're going to put point C right here. And we're going to have a ray coming off of this, and we'll call that D, so we have a ray CD. Now, I'm also going to tell you that segment AC has a length of 2x plus 3, and ray CB has a length of 4x minus 5. There you go. All right, a little bit more information. I'm going to tell you that ray CD bisects segment AB. And what I want you to do is to find the length of AC. Notice no bar above it. That means we're looking for length. And we also want to find the length of AB. All right. So that's the task. Well, let's see here. What can we do with this? Well, let's start with what we know here. We know that CD is a bisector, which means we know that C is the midpoint, and that means, as we saw up here, that that means that AC is congruent to CB. All right, so I'm going to write that down right here. AC, segment AC, is congruent to segment CB, which means that the length of AC is equal to the length of CB, right? Because it's congruent. Great, lovely. What can we do with that? Well, what we can do with that, color here, I can plug stuff in. I know the length of AC. The length of AC is 2x plus 3, so I'm going to put that in. 2x plus 3 equals the length of CB, which I know to be 4x minus 5, and now I have an equation. I can solve for x. So let's do that. Okay, first let's move the x's over, so minus 2x minus 2x. So 3 equals 2x minus 5. Add the 5 up to both sides. 8 equals 2x. I only want 1x, so divide both sides by 2, and I end up with x equals 4. Okay, good. I know that x equals 4 now. What do I do with that? Well, I need the length of AC, and I know AC is 2x plus 3, so let's do this. AC equals 2 times x, which I now know to be 4, plus 3. So, AC equals, let's see, 2 times 4 is 8, and 8 plus 3 is 11. And there it is. I have AC. Put a box around it so that geometry teacher can find my answer. Okay, next thing, we need to find AB. Okay, well, AB is the entire length, right? So, what I can do here, segment addition postulate, right? Okay, so I'm going to move here. AB is going to equal AC plus CB. But the thing is, I know AC now. AC is 11, and remember, AC equals CB, which means CB also equals 11. And so AB equals 22. So the length of AB is 22 units. Again, got to put a box around it so my geometry teacher can find the answer. So not too bad, right? Pretty simple stuff so far. And most of this is. But now we're going to talk about partitioning a segment on a number line. This, not quite so simple. All right? Sometimes, but not usually. Fairly complicated, but not terrible. It's not like some of the other things we'll do later on. So here we go. Partitioning a segment on a number line. Partition means to cut it into pieces, to separate things, right? So what it wants us to do, for segment JK, so here's segment JK, with endpoints at coordinates x1 and x2, the point P, with a coordinate of this lovely mess, partitions the segment at a ratio of B to A. All right? So what this says is the ratio of JP to PK is B over A. So you see here, for example, the ratio would be 1, 2, 3 over 2. That's the ratio. And so looking at the numbers like this, I know it's a little bit confusing until you actually do an example. So let's do an example. All right? Okay, so we're going to be flipping back and forth to this. Open it up. Let's see here. Example 1. The endpoints of segment AB are at 2 and 8. We want the coordinate of point P that partitions the segment in a ratio of 2 to 1. All right, so I'm going to draw this on a number line. I'm a visual guy. It helps me this way. So here is A, which is at 2. Here is B at 8. And somewhere in here, I don't know where, but somewhere I'm going to put point P. And wherever it is, this distance is going to be twice that distance. Okay? That's what it's saying when it says 2 to 1. Okay? So what we need to do is we need to take a look at our ratio, formula here, right? So we need A times x1 plus B times x2 over A plus B. And looking at this, our ratio is going to be B to A. Okay? So let's see. x1 is the first point, and A is that second number in the ratio. So this is x1 right here. This is x2. A is the second number in the ratio, which is a little weird, and B is the first number in the ratio. Like that. Okay, so now we plug stuff in. Okay, so we had, what was it again? A times x1. Okay, so A is 2. times, oh, sorry, A is 1. A is 1. Where's my whiteout? I was looking at x1. There you go. Mistakes never happened. Didn't make any mistakes. You don't see anything. All right, so A is 1 times x1, which is 2. Then what? Plus B times x2. All right. So plus B, which is 2, times x2, which is 8, divided by, what was it? A plus B. All right, so A is 1 plus B, which is 2. All right, so this is where point P is going to be. So let's work this out. Let's see, multiplication first. So 1 times 2 is 2. 2 times 8 is 16. And 1 plus 2 is 3. 2 plus 16 is 18 divided by 3. And 18 divided by 3 is 6. So P equals 6. 6. Now, if we look at this to check it, all right, let's check this. The distance of AP, right? AP has a length of, well, from 2 to 6, that's a length of 4, right? PB has a length, well, from 6 to 8 has a length of 2. Is this 2 to 1? Is 4 2 times that? Yeah, so we put in the ratio, and this does equal 2 over 1. So we're good. P equals 6. All right, next example. Next example right here. Okay, so let's take a look at this. Segment, endpoints of segment EF. So EF are negative 3 and 7. All right, so that means this is x1, this is x2. And P is going to be somewhere over here. We have a ratio of, okay, 4 to 1. And remember, the second number in the ratio is the A. So this is A and this is B. All right. So that means that the equation for this, the formula, we have P equals A1 times x1, negative 3, plus B, 4, times x2, 7, over A1 plus B, 4. All right, so let's work this out. We've got negative 3 plus 4 times 7, which is 28, divided by 1 plus 4 is 5. All right, so negative 3 plus 28, well, that's a negative there, so we're subtracting, so that is 25 divided by 5, and so we end up with P equals 5. Right? Okay, that's good. Let's check our work, make sure we did this right. So let's see here. The length of EP. Well, from negative 3 to 5 would be a length of 8. And PF, from 5 to 7, that would be a length of 2. So put this in our ratio, simplify that down, and yes, that is 4 to 1, so we're good. All right, there it is. A little bit weird. The formula is not the most fun formula to use, but it works, and it's not completely terrible. The tricky part, order is very, very important on this. Whichever number comes first, that's x1, and the second number in the ratio is A. Okay, very, very important you get those right. All right, last thing we're going to talk about here is the midpoint of a segment on a coordinate plane. All right, on a coordinate plane. And the formula for this is much easier. What you're going to do, very simply, is you average the x's, you average the y's. So you're going to take x1 plus x2, divide by 2, that's your x coordinate. You're going to take y1 plus y2, divide by 2, That's your y coordinate. This one is much, much simpler. So let's do 2 examples of this, and we'll be done. All right, so here we go. Endpoints of segment RS, it shows us, are at 1, -3, and S at 4, 2. We need to find the coordinates of the midpoint, point M, which is going to be somewhere there. Can't really tell where it is because it's not on the grid line, so we don't know. We're going to have to work this out. That's fine. Midpoint is x plus x, so 1 plus 4 divided by 2. And then y plus y, so -3 plus 2 divided by 2. Well, let's see. 1 plus 4 is 5 divided by 2. Well, that's 5/2. All right. -3 plus 2 is -1 divided by 2. Right there. And neither one of those simplifies, so we can call that our answer. 5/2 and -1/2. All right. If you prefer and your teacher really likes mixed numbers, you can change this and say that M is at 2.5 -1/2. That's fine. Personally, I like improper fractions. I think they're good. As you get higher and higher up in mathematics, improper fractions will be preferred and they will be easier to deal with. However, on a number line, it is easier to find 2.5 rather than counting over 5/2. So either way, there it is. All right, that's pretty easy stuff right there. So let's take a look at this. In fact, actually what I would like you to do is to pause the video for a moment, work this one out on your own, and then come back and see how you did. All right, so let's see how you did. We need the midpoint of segment J. Oh, no, we're told the midpoint of segment JM is 2, 1. One of the midpoints is at 1, 4. We need to find the other endpoint. So this one is a little bit tricky. Let's see here. So our midpoint formula, we have, okay, so this is going to be a little tricky. We're going to start with this. So we have, just take the x's. Okay, so we have 2 equals x1 plus x2, which we'll call this an x2, plus 1 divided by 2, right? Because our midpoint is at 2, 1. We are looking for k, so we got to figure out what k is. All right, so we'll just work this out. So first thing we're going to do is we are going to multiply both sides by 2 to get rid of that 2 there. Right, and so we have 4 equals x1 plus 1. Subtract 1 from both sides, and we end up with 3 equals x1. So 3 is our coordinate, x coordinate for k. All right, now let's look at the y coordinate. So 1 equals y1 plus, what was the y? y2 is 4 divided by 2. And we're going to do the exact same process. First we multiply by 2, multiply by 2. So I end up with 2 equals y1 plus 4 minus 4 to both sides. And so 2 minus 4 is -2. And so y1 is -2. So -2. And this is my answer. Now, let's check this just to make sure we did it right. We have a graph. Let's see if this works. So I have the midpoint, M, is at 2, 1, right there. That is M. Ready? M. J is at 1, 4, right there is J. And so, let's see here. I need a straight edge, which I don't have on my thing. So I'm just going to grab a sheet of paper here, fold it in half, now I've got a straight edge. Alright, so my other point here I said was at 3, -2, right here. Let's see if this works. Let's look at this. And so here is K. So is M in the middle? Well, let's see. We went down 3 over 1 to get from J to M, and down 3 over 1 gets from M to K. So these are, in fact, congruent because they have the same length there. And so that works. All right. So hopefully you found this useful. All right, just to refresh, the midpoint on a coordinate plane, average of the two x's, average of the two y's. Partitioning, important thing on this, partitioning on a number line, whatever point is listed first is x1, whichever point is listed second is x2, and A is the second number in the ratio. And the easy stuff, midpoints, divide your segment in half, so you have two congruent segments, and a segment bisector just is something that goes through the midpoint. All right, so there it is. Hopefully you found this useful, and I will see you next time.